All right, in this example, let's write down the problem that I'm looking at here. This is problem number 6. And this is where the log equations are going to start getting a little more interesting. This one says log base 2 of x minus 8 in this example plus 2 equals log base 2 of x squared minus 16x plus 64. Okay, so right away, something here should be raising alarm bells. I've got like a whole polynomial term stuffed in the argument of one of these logarithms. So one of the things we've been doing so far is trying to either get an equal log on both sides or condense the logarithms so you have a log on one side with a number on the other. And if we go ahead and try doing that, let's see what we get here. I'm going to leave the number 2 on the left. And on the right, I'm going to say log base 2 of, and you take this whole big polynomial thing, x squared minus 16x plus 64 minus log base 2 of x minus 8. And you may be looking at this like, okay, fine, but what are we going to do with that x squared minus 16x plus 4 thing? It's really not so bad, just you have to think back to, maybe we haven't done this in a while, but factoring. We're not done with factoring yet. We'll never really be done with factoring. You have log base 2 of, what is this thing? Well, when I see x squared minus 16x plus 4, I think about what the, oh my gosh, that's 64, not 4. When I see that, I think, what are the numbers that multiply to 64, but they add up to 16? Okay, that's x minus 8 times x minus 8. Okay, just factored that out. And it's minus logarithm base 2 of x minus 8. Okay, so we factored the polynomial. This doesn't look so scary now. If I'm going to combine these logs, you see some things are going to cancel out. And that'll be nice. You have log base 2 of, this is going to get a little bigger, by the quotient rule. Okay, we're going to use the quotient rule to combine these two logarithms. The x minus 8s are up top because this polynomial on the left is a positive polynomial. But if you look at the polynomial on the right, okay, that's a negative sign. So this is going to be an x minus 8 in the denominator. Okay, and what happens now? Well, you have an x minus 8 down here, x minus 8 up top. Those cancel out. And you get 2 equals log base 2 of x minus 8, which is not so hard to solve. Just convert it into exponential form. That's what you do when you have a number on one side, log on the other. So I'm going to say, well, 2 squared equals x minus 8. Okay, and the order that I'm reading these steps off to do that is I say 2, that's the base, to the exponent, so 2 squared, equals the argument, x minus 8. So now, if we have 2 squared equals x minus 8, well, that's just 4 equals x minus 8. Add 8 to each side, we get x equals 12. Now, before you just call it good and done, let's just be careful and check x equals 12 against the original arguments up here. Remember, log base 2 of x minus 8. That argument better be positive, and you see, yes, 12 minus 8 is a positive number. Okay, so this is going to be the logarithm of, well, 4 is the argument. And it's not important whether that's easy to solve. The important thing is that is a positive number. And if it's a positive argument, then it's legal to write as a logarithm. So this solution looks like it's good.